Hello everyone. In this session of CCNP ENCOR series, I'll discuss high availability technologies such as SSO, NSF, GR and NSR. Imagine a pilot flying an aeroplane with a co-pilot, and this co-pilot is ready to take over if something goes wrong during the flight. In networking, we have a similar setup to ensure uninterrupted service using high availability technologies. To achieve high availability at the system level, one of the guidelines is to have redundant RPs on Cisco routers. In routers with redundant RPs, also called supervisor engine on some platform, one RP is designated as active and other is designated as standby. The active RP manages the control plane, which includes tasks like maintaining routing table, and in some architecture, handling centralized forwarding. The standby RP is there as a backup, ready to take over in case of a failure. But here is the issue. And to explain that, let me have a small network in which I have three routers: P router, PE router, and CE1. The CE1 is the customer router and PE is the provider edge router. Actually, these terms are used mostly in the service provider side, like the PE is the provider edge which connects to the customer end, customer edge you can say. So coming back, the PE router has redundant RPs. RP1 is acting as an active RP and RP2 acting as a standby RP. And then I have a one line card just to demonstrate. It handles the data packets, whereas RPs, the active RP handles the control packets along with the OSPF adjacencies or protocol adjacencies. Now, here is the thing. When the active RP fails, so if the active RP fails, the standby RP takes over and rebuilds the routing table and fib, during which the routing protocol adjacencies will drop. This can lead to packet losses and network instability. And to address this challenge, routers use high availability technologies. These high availability technologies helps us to keep forwarding packets non-stop even during the RP switchover. And these technologies are SSO, NSF, GR and NSR. These technologies are to be used in conjunction with each other. You cannot just enable SSO or NSF. You have to use them in combination. They are like a puzzle. These technologies rely on Cisco Express forwarding or Ceph entries in the fib. So packets don't get dropped while the routing protocol re-establishes the adjacencies. Let's look at these technologies one by one. So what is SSO? SSO, also known as Stateful Switchover, is a feature that provides internal redundancy within a router or switch with dual RPs. SSO keeps the active and standby RP synchronized, and this ensures that the router's configuration, line card operation, layer 2 protocol states, ACL, QoS tables are mirrored from the active RP to the standby RP. And the process of mirroring this information between RP is known as checkpointing. Now, during a failure or a switchover, the standby RP becomes the active RP and uses the synchronized information to minimize the disruption. But there is a drawback. SSO doesn't checkpoint any layer 3 control plane information. If you see on the left, it mirrors configuration, line corporation, layer 2 protocol states and everything, but it doesn't checkpoint any layer 3 control plane information about any neighboring router. And due to this, the existing routing protocol adjacencies will flap, and then the routing tables will be cleared because of that. Because of this, an interruption will occur at layer 3 for a while during the switchover. So this is where the NSF comes into the play. NSF, also known as non-stop forwarding, is a feature focused on layer 3 redundancy. It frequently checkpoints and updates the fib entries from the active RP to the standby RP. This keeps the fib operational even when the control plane is disrupted due to the switchover or if it crashes. So NSF ensures that traffic keeps flowing during a switchover while routing adjacencies will re-establish. Once the routing adjacencies are restored, the fib is updated with the latest topology information. Now there is a drawback in this as well. During switchover, though the local router will continue forwarding, but the neighbor routers detect the routing adjacencies going down and may stop forwarding traffic to the router. You got my point, right? The local router will not be affected. The NSF will make use of the updated fib during the synchronization. It will use that information to forward the traffic, but the neighboring adjacencies will detect the control plane failure and will drop the adjacencies. And this will definitely affect the data traffic as well. So to avoid this, we have another HA technology, or two types of HA technology, that is GR and NSR, which we will discuss now. Before that, let me tell you an important point, that NSF isn't a standalone feature. Okay, it is automatically enabled when you have SSO enabled, and nowadays in the routers SSO and NSF are by default enabled. So that's why these features are commonly referred as SSO/NSF if you find it in the documentations. So let's get back to the other technology, that is GR. GR, also known as Graceful Restart, is a HA features that allow a router to switch over its RP or control plane without dropping the traffic. I would say it's like hitting restart on your computer or laptop while your download keeps on continuing without interruption. So GR refers to the capability of the control plane to delay the absence of or delay advertising the absence of peer for a grace period and allow the failure or switchover of a RP to go undetected for a period of time. Give me a second, let me connect my power or else I will get disconnected. Okay, here I have the power back. Okay, so I was saying GR refers to the capability of the control plane to delay advertising the absence of peer for a grace period. This allows the failure or switchover of an RP to go undetected for a certain period of time. It ensures that neighboring devices temporarily retain routing adjacencies and routing information when the router control plane restarts. And to understand this, we need to understand the role taken by those routers. Here I have again added another customer just to tell you the different roles maintained by the GR routers. So the GR capable router, this router has the router that has a dual RPs and supports SSO and NSF, you can also call it as a GR capable router or SSO NSF aware router. Then you will have a neighbor router that has a single RP, but it is GR aware. Got my point? Like any router that has a single RP but supports GR is called a GR aware or GR helper router. Then you have another router which doesn't support GR and is not aware of GR. That is called GR unaware. that is our customer H2 router. Let's see how it works. Now we know the role of the routers. These are important because you will come to know when you know how it works. Here I have a PE router with active and standby RP, right? The active RP manages both the control plane and the data plane. The standby RP is ready to take over in case of failure. So when the active RP fails or restarts due to software upgrade or crash, the standby RP will take over. And during this time, during the switchover time, the role of GR comes into play. The restarting device, it notifies its neighbor about the restart. The neighbors hold on to the adjacency and routing information for a grace period. By default, it can be 30 seconds. You can optimize it as well. So during this period, GR aware neighbor keeps forwarding traffic as if nothing happened. And the GR unaware, now you will come to know why I have put this router. The GR unaware will drop the neighborship because he doesn't understand the grace period. So it will drop the neighborship and the data traffic will drop. So as I said, during this period, GR aware neighbor keeps forwarding traffic as if nothing happened. If you see on the left, P router and C router, they are GR aware, so they keep forwarding the traffic for that grace period. And during which the new active RP, that is our earlier stand, RP2, uses the grace period to rebuild routing protocol adjacencies with neighbors and then synchronize its routing and forwarding table without disrupting traffic. So GR works with SSO NSF to ensure that neighbor routers continue forwarding traffic during RP switchover. It has to be used in conjunction with SSO and NSF. So GR is the only feature that interacts with the peer network devices. If you see previously, SSO and NSF are locally, you have to, whatever you do with SSO and NSF, that impacts local on the local router. But GR interacts with the peer network devices. So the downside of the GR is protocol dependency. Now, both the restarting device and its neighbor must support GR for it to work. If the neighbor doesn't support GR, then it's useless. And if the peer completely fails and never comes up, this will affect the overall network convergence. Like if the grace period expires and if the neighbor doesn't come up, then again it will have to re-establish everything. That is one of the second drawback. Which brings us to the final concept, that is NSR, also called non-stop routing, is an internal feature on Cisco router that enhances redundancy during RP switchovers. With NSR, all the protocol state required, the control plane protocol state required to maintain peering state is precisely synchronized across the active and standby RPs. The active RP constantly checkpoints control plane information like routing adjacencies and TCP connections to the standby RP and ensures continuous packet forwarding during RP switchover. The neighbor will not even feel the switchover has taken place. It will be instantaneous. The failure is handled internally and it is hidden from the neighbors. Unlike NSF and GR, NSR doesn't rely on neighboring devices for high availability. It is an internal feature. It ensures seamless control plane failover, as I said, and protocol continuity. So it is good, but again, there are some drawbacks. NSR is very complex. It increases the router's workload and requires significant hardware resources because it's always checkpointing the data between RPs. It checkpoints all the control plane data, as I said. To summarize, I would say SSO provides seamless control plane failover, whereas NSF ensures, SSO provides seamless control plane, but it misses the layer 3 control plane information, where the NSF ensures the data plane remains operational by checkpointing the layer 3 information, but again it depends on the neighbor support. GR, it preserves protocol adjacencies during restarts by coordinating with neighbor, but it expects other router to be GR aware or GR helper, I would say. And then the NSR is mostly in the independent solution. I mean, the most independent solution maintains full routing continuity without relying on neighbors, but at the cost of high router resource optimization, resource utilization. So the recommendation is to use SSO plus NSF when you need both control and data plane continuity, along with either GR or NSR. So it depends on whether the neighboring routers, whether it supports GR or not. Or you can always go ahead with NSR if you have enough resources in your router. That's it for this session. I hope this was informative for you. In my next session, I will discuss about FHRPs. Thank you for watching. Please do like, comment, share, and subscribe. And also please do not forget to check out my courses on Udemy. I'll be sharing the link in the description below. Thank you for watching.